people like 5 more minutes and then we just kick it off. Okay, awesome. I think I'll just kick it off and then yeah, I'll just kick it off and I guess people will get a recording out of this. So welcome guys for our Wednesday session. I can see we are less today, but maybe hoping that maybe some people are affected by I know most people are affected by the electricity issue. Some other people, of course, yeah. So probably we'll just kick it off. So we the whole of last month, because today is 1st of May, the whole of last month we've just been doing a series of meme tokens, yeah. So we of course started from the very scratch, learning about how to create a meme token, like what you're required to do, and everything, like the steps, the first steps before you even come to the coding aspect of it. Yeah, so today we are gonna be using a very interesting language known as Motoko. Yeah, the reason why we are using Motoko today is we said in this meme token series we're gonna be using three languages. We're gonna be using Motoko, we're gonna be using Rust, and we're gonna be using TypeScript. Yeah. So based on my findings, according to how I've seen most people build on the ICP ecosystem at the moment, most people have built their tokens using Motoko. We also did a Rust one, and also last week I guess Samuel also did one for Motoko, also another token which was actually very interesting, mintable token. Yeah, so we are still gonna come back to Rust. So the good thing about this series is we actually didn't do it in vain, because we are gonna be having an upcoming meme-thon that is gonna be happening this month, around 17th to 19th, and yeah, we are welcoming most of you guys to join in and at least kick in. So if you've been attending most of this series, I think you're a bit ahead of time, yeah, because basically this is what you're gonna be also just doing over there, so at least you'll be steps ahead. So my repository today is this one, but I'm hoping that you're gonna reach um that side. So let me just post it right now on the Telegram group. Yeah, so we're gonna be following through that repository step by step, and see how we're gonna do the backend side, and also the front end side, yeah, of our particular meme coin. Yeah, so as you all know, Motoko is the main language for internet computer. um when you check out those Motoko, when you just click here on the Motoko sector at the internet computer website, it's gonna prompt you to somewhere over here, yeah, then you get to see no, really, what is Motoko, yeah. So it's a programming language, of course. It's new, modern, and type-safe language for developers who want to build in the next generation of distributed applications to run on the internet computer blockchain network. Based on, according to me, I feel like how I've interacted with Motoko, I understand it's more of like Rust and JavaScript combined somehow in a way. So and that's why we call it, yeah, Motoko, yeah. Of course, it's a program for the internet computer, and maybe basically just basic things you need to know about Motoko is um a canister smart contract, or canister um a canister smart contract, or canister for short, is expressed as a Motoko actor. So an actor is an autonomous object that fully encapsulates its state and communicates with other actors only through a synchronous message. Yeah? Basically, in short, it's just meaning that um, when you're gonna be programming with Motoko language, there's always gonna be an actor model somewhere. Usually, an actor is now you as the developer, yeah, you as the person who is actually programming that particular token, yeah. So this is just a simple um Motoko code, and is the actor counter. This is just an increment code, yeah, counter code, where you can just add +1 or something, yeah. It has an actor model. The actor here is a counter, so it has a variable, which the variable here is the actual value, and our value here is 0. It also has a public function. The public function is, this function of increasing, like an increment increase, of course. Yeah, and with that, you also return a value of, let it add +1, over here, yeah. You can always put however value you want, yeah. And then of course it has to return the given value. So of course here when you check on this particular code, it's just gonna add, 1, 0 plus 1, probably you're gonna get that particular output, yeah. So these are just basics you can know about Motoko. This is also another particular setup. Always what you need to remember about Motoko is there's an actor model somewhere, there's a variable, and now there's a public function that has to return something, yeah, just like all the other languages that you usually use in your day-by-day coding life, yeah. So I'm gonna just brush through this. Another maybe important thing that I'd love you guys to know, so you can check out more of these documentations. Just post them also on the Telegram group. You can just check out, learn more about Motoko. If maybe you feel that you're new to this, it's always good for you to at least just read the documentation, because that's actually where you're gonna get to get be advanced in your particular building. Yeah. So another thing you need to know about Motoko is at some point you might be required to at some point you might be required to actually, yeah, so it's gonna be your work to just go through all this and check and understand the whole basic concepts about Motoko and stuff. But yeah, there's always you can always use a Motoko package. Motoko comes with a package that is known as a Motoko package. So this one is actually essential for developers. Mostly if you're building with Motoko, you're gonna be interacted with it one way or another. Sometimes you might not have to use it, but most times you can actually get to use it. So there's actually a way where you can actually configure this. So on my end, I have already done this whole installations and the Motoko packages in case I'll need to use them in my particular project. Yeah. So I'll just post the link also over there. You can just check it out also in case you need to use Motoko packages and stuffs. Yeah. So I'm not gonna go through that for now, but I've already gone through the whole of these steps and actually like installed this, checking out different packages and how they actually help. So Motoko package is like an independent package on its own. It's more like cargo. When doing Rust, it's more like the cargo TOML files, and more like, yeah, that whole assembly language that it's actually written in. Yeah. So yeah, so let's just go to our meme token. I was just telling you guys some small bit about, yeah, about Motoko. Yeah. So we said that we're gonna be doing a meme token, and we did an ICRC1 uh, token during most of our sessions of last month. Yeah, we actually even showed you guys how to set up an ICRC1 ledger. So if you didn't see, at least I did it, and also Samuel also at least um made sure he repeated it. You can always check how to just set up an ICRC1 ledger. Basically, the ledger is in charge of doing most of the transactions, because when you're talking about a token, now here it's a meme token, but any type of token, there's always has to be transactions somewhere, so there has to be also a ledger. So if you didn't check out how to set up an ICRC1 ledger, you can just um yeah, check out those other video video recordings. Yeah. Yeah, so I just wanna just wanna do something here. Yeah, so of course an ICRC1 token is the uh, Internet Computer Request for Comment standards. It's basically at the moment it's the like the first fungible token standard on the internet computer. Yeah, and through this the ICRC1 standard was created by a working group and is designed for fungible tokens such as CKBTC, CKETH, and SNS tokens. Yeah, for those of you who actually have been interacting on the internet computer community at the moment, we had like a whole airdrop where people are getting Motoko Sentinels, and most of what we were using is CKBTC. When you have um, your particular NFT, you can always trade it using CKBTC. So that's how much an ICRC1 token is powerful in the on the internet computer chain. If you're comparing it to other chains such as Ethereum, it's just the twin of an ECRC20, Ethereum request for comments 20 type of token. Yeah. So there's that ICRC1 token that came about. Yeah. But as the Definite team has been as the whole ICP community has been growing, this particular token has not been the only one. There has been an ICRC2, there's been an ICRC3, and there's been an ICRC4 at the moment. Yeah. So the only difference is an ICRC2 token standard, which we are dealing with today, is just an extension of an ICRC1 token standard. So that's why you need to first understand what the power of an ICRC1 token before you start coming on the ICRC2 type of token, yeah, and the ICRC3 and the ICRC4, yeah, because it's like the foundational one. So an ICRC2 token standard is an extension of an ICRC1 token standard, and it incorporates two particular functions that an ICRC1 type of token does not have. So it incorporates the approve and transfer operations. So the approve and transfer operations are actually very, very, very critical. When we were doing our introduction, when you go back to the series of this whole meme coin series, we checked out these different types of methods and functions that are actually needed. Yeah, if you're dealing with any type of token, yeah, there has to be an approve and a transfer, because when you're talking approval and transfer, it's you're dealing with an account somewhere. Yeah. So basically that's what an ICRC2 token is. It's just an extension of the ICRC1 one. Yeah. Then allow me to go just ahead a bit. Today we're gonna be we're gonna be a bit we're gonna be a bit on the theory basis, and we're just gonna see a bit of code part of it, because it's always good to first understand the theory part before you reach the the actual coding sector. It's gonna be easy to understand. So as you can see, it's just an extension of an ICRC1 that you need to know. It specifies a way for an account owner to delegate a token transfer to a third party to the owner's behalf. Yeah, so imagine a whole scenario whereby you have this particular canister smart contract that not only can it hold your particular cryptocurrency or meme coin, but it can also, when you just give it a particular command, it can be able to do token transfer on your behalf. Like, give it this function and it just does that whole particular function. So so since an ICRC2 token leverages the approve and the transfer flow, we are picturing a scenario whereby there's an account owner who is called Alice, yeah, and this Alice entitles Bob to transfer this particular let's just say X tokens from her particular account. So assume you have like tokens in your account, and you wanna call the ICRC2 approve method on the particular ledger, where transactions happen. So once you make that function, probably you can do it by a particular click of the button in your particular application tab. So number two, Bob can transfer up to X tokens from an account A to any account by calling the ICRC2 transfer method on the ledger as if A was Bob's account B. So Bob can actually transfer the tokens from that particular account A to any account by just calling the ICRC2 transfer method. So basically these are two methods whereby one approves and the other one just does the whole transfer method. So an approve always has to go with a transfer somewhere. So let's just continue. The number of transfers Bob can initiate from an account A is not limited as long as the total amount spent is below, of course, X amount of tokens. So approvals are not transitive. If Alice approves transfers from account A to Bob's account B, and approves transfers from his account B to Eva's account. Now there's a particular third party called Eva. Eva cannot withdraw tokens from Alice's account through Bob's approval. Always, that's why it's always good to, Canister smart contracts are powerful because someone cannot do something on your behalf. No one can release and also in the blockchain side, no one can release particular tokens without your particular approval and act as a third party in a sort of type of way. Yeah? So the approve and the transfer methods, um, they basically became popular in the Ethereum ecosystem. Yeah, thanks to the ICRC20 standard. For those of you who have not started exploring Ethereum, I think almost all developers who come on the blockchain side love to explore Ethereum. Yeah. So this interface, of course, it enables new applications capabilities whereby, of course, Alice can approve a large amount to Bob in advance, allowing Bob to make a periodic transfer in smaller installments. Yeah, so you can always create a whole system. It's more like, you see, like when you take a loan right now from a particular bank, there's always a system where they have set that on this particular date, when it reaches this particular date, you'll always be required to pay that particular loan. Maybe let's say you're paying it in installments. Yeah, so when you don't pay it, of course, in that particular time, there's always you can get a notification, you can get any form of communication that, hey, this system is actually has been set up like this and this type of way. Yeah? So the approve and the transfer method is always really good. It's the same way that particular bank can't actually okay, they have the right to snatch any amount of money from your particular account based on your approval, yeah, of taking that particular type of loan. So canisters that are implementing the ICRC2 standard must implement all the function of an ICRC1 interface. That's why I insisted you first need to learn about the ICRC1 before you go to the ICRC2, because we are still all building behind ICRC1. It's just that we're giving it more hybrid features. So canisters that are implementing the ICRC2 standard must also include ICRC2 in the list returned by the ICRC1 supported standard method. We're gonna see that in code. There's different types of methods of ICRC2 that you can check out. For example, there's this ICRC2 approve method. This method entitles the spender to transfer a token amount on behalf of the caller from an account from a particular account. So that's just that. So the caller does not need to have the full token amount on the specified account for the approval to succeed. Just enough tokens to pay for the approval fee. Just go forward. There's also another method. There's the ICRC2 transfer from method, which it transfers a token amount from the account. I think from the account to the account that is using the allowance of the spender's particular account. So this actually, just like we said, the approval and the transfer, it always needs a ledger. There's always the ledger is the one that is like the whole third party of this particular smart contract. So the ledger withdraws the fees from that particular account once, of course, you want to transfer them. And there's the ICRC2 allowance method, which just returns the token allowance that the spender account can transfer from the specified account and the expiration time for that allowance, if there is any. If there is no active approval, the ledger must return that particular balance. There's the ICRC1 supported standard, which just returns the list of standards the ledgers support. Any ledger supporting an ICRC2 must include a record with the name field equal to ICRC2 in that particular list. So imagine a scenario whereby Alice is depositing tokens to canister C. So Alice wants to deposit 100 tokens on an ICRC2 ledger to canister C. So Alice calls an ICRC2 approve with the spender set to the canister's default account, and the amount set to the token amount she wants to deposit, her 100 tokens plus the transfer fees. So she first calls the approve method, and then Alice can then call some deposit method on the canister, which calls an ICRC2 transfer to seek the approval and then the transfer, from this, okay, I think all this I read each other, with set of Alice's account, I think I put from twice. So the canister can now determine from the result of the call whether the transfer was successful. If it was successful, the canister can now safely commit the deposit to state and know that the tokens are in its particular account. So this whole many words is just a whole scenario to just explain to you how these particular methods are really important in an ICRC1 token. That's why I just named it an ICRC2 token standard on internet computer. So here's a scenario where I can start C now after that particular maybe task that has been given. Can start C now transfers tokens from an Alice's account to Bob's account on Alice's behalf. See how powerful that is, so I'll just not read through all this, but so now imagine a scenario now where Alice removes her allowance of canister C. So Alice wants to remove her allowance of 100 tokens on ICRC2 ledger for canister C. Alice calls the approve method, of course. And then there's a scenario where the canister can no longer transfer tokens on Alice's behalf. Probably maybe Alice does not have maybe that particular amount of tokens in her account. There's also a scenario where Alice automatically removes her allowance for canister C. So I'm just gonna rush ahead, and we're actually good to go. So that's just a whole basic introduction of what an ICRC2 token is and how important it really is. Maybe another thing I can just remind you, maybe for you to just remember, is I'll just take you back to the ICRC1 token. So when you're talking about an ICRC1 token, you're always talking about where is your data stored. So where your data stored is, there's a particular account and there's always a sub account somewhere. There are different ICRC1 methods, just the same as the ICRC2 ones that we have gone through, but this one, it's always important to also know, because I guess as far the only two major methods on the ICRC2 side is the approval and the transfer one that you've actually seen. But there's always this basics one on the ICRC1 token that you'll always have to include. So like this one, then ICRC1 name method, which just returns the name of the token. There's a symbol method, there's a decimal method, there's a fee method, there's a metadata method where you actually store your data. There's a total supply of those particular tokens. There's always the minting account. Minting account is always important when you're talking tokens. The minter is now the one that is a minter is as powerful as it's the one that is actually producing your actual tokens. So imagine a scenario whereby you right now you want to create a token where the whole world is going to be using, or it doesn't have to be the whole world, it's just a particular community that has come and is really together. Yeah, so a minting account is really important because it's actually the account that creates the whole tokens out of air. That's why people always say that blockchain is really interesting, because we create money out of literally nothing. We create it out of the cloud, and that's how Bitcoin has succeeded. And probably most coins are also gonna we're gonna see how they go through. Yeah, and these are actually the particular tokens that we want you guys to also build. Yeah, so there's also a balance of particular method. You can always see there's always an ICRC1 supported standard methods. Now that's where ICRC2 comes in. Yeah, so I was just explaining to you that. Now let's go to our particular coding. So I hope that at least has laid a bit of a foundation of what you're actually gonna be dealing with. So when you're talking tokens, we're gonna be going deeper and deeper as we continue. Imagine these are some of the tokens that actually are currently on the internet computer, the ICRC1 and ICRC2 that we have done so far. We're gonna be seeing NFTs, for example, those who received like the Motoko airdrop NFTs. We're gonna be seeing how do you actually create that particular NFT marketplace, using an ICRC7 token. So this token this token topic is really interesting and huge in the internet computer, because all companies need this particular token. So if you actually are good at it, or actually if we just come together and maybe let's say work on a particular project, we can even say everyone who is actually here can contribute something out of a particular project. We just open source it, and you never know, you can always see how it goes. Yeah, that's why we usually share these particular GitHub repositories with you guys. You can always chip in the way you want. For example, this one that I posted, check it out. Like fork it. Check out maybe what are the features you can add on your end. That's how people always end up doing collaboration. That's how actually even in this upcoming meme-thon that is coming up, you can actually get to learn and grow, because this meme-thon is unique because we are competing against all the other hubs in the ICP ecosystem. Yeah, so I'm really hoping that most of these good projects are gonna be coming from our particular side. Yeah, so I've done enough talking. Now let's go to the code aspect. Yeah, so yeah, so allow me to just minimize this. I'll just open my particular terminal. So Control Alt T. Yeah, I'm just waiting for it. Yeah, so we're doing Motoko, of course. For the basics of those who always don't know, let's name our project. I'm gonna name it ICRC2. If I'm gonna name it there, let me cd it in the documents folder, because I have the same particular folder in my home page. So let me just cd yeah, and then yeah, so I think I just yeah, no, actually I need to go to the documents folder. Yeah, perfect. So dfx new, we want to name it as ICRC2. I'm trying to name it that way so that it doesn't ICRC2, yeah. We're gonna be select Motoko. I'm gonna select I want to use simple van HTML and CSS. I'll select internet identity for our particular front end. So of course it's gonna create for you your whole project. The good thing about building on ICP is most of these things you don't need to do basics like from scratch. It's just run a particular command and everything gets set up on you. Now you from there is when you get to input the particular data. Yeah, it's so powerful, right? That's why being a developer is actually considered a very powerful feature because you're literally also creating nothing, um, something out of nothing. Yeah. Now we're doing meme tokens. We're creating meme tokens out of the cloud, out of the air, and we want people to actually use this particular meme tokens. Yeah, another thing maybe I forgot about tokens is I said there's always a minter. The minter is actually important, but there's always a banning feature. So the banning feature um is also really important because it's the one that actually the banning feature is the one that actually puts the minting feature in check. We can't just print tokens out of the blues without actually minimizing them. It doesn't really make sense. So the banning feature is always has to be. You always have to ban some tokens. That's why even this particular meme coins like Shiba Inu, like Pepe, what they always do is they always try as much as possible, like the developers, the people who actually built those particular tokens, they try as much as possible to ban them from existence so that the value can go up, same way as the way Bitcoin has done. The value of Bitcoin is scarce. There's only 21 million Bitcoins that's going to exist. So the more the years on the edges go, the more we actually getting to implement this particular feature. So banning is also important as much as the minting feature. So I was just explaining that as our project was coming through. So for that, I'll just do cd ICRC2, and yeah, let me open my particular project with VS Code, yeah, because everyone is using VS Code. You need to use VS Code, of course, when you're building on ICP. And yeah, here's my particular project, yeah. Yeah, so yes, so here's my particular project. When you check it out, of course, you're gonna see the backend side, you're gonna see the front end side. The backend side has a main.mo file. That's actually where we're gonna input our backend files. On top of that, you're gonna add other particular folders on the backend side. The front end side is just simple vanilla JavaScript, which always has index HTML. This one is using index ICSS for the particular, for the front end features. Those are just normal features. That's why it's so fun building on ICP, because you don't actually need to stress about the front end and stuff, because we're literally building everything on the computer. And in all machines, one thing you always realize is there's always a HTML code somewhere. In all languages, there's always a HTML code somewhere. It's actually what um, is a powerful feature on the web. So I personally like to use index HTML, but um, for those who are actually really good in JavaScript, you can always use React. Some people, they just have to use React for their front end. React is so powerful, it's so good, and the good thing about React is maybe that it has an advantage of index HTML is React. You can always build the back end and the front end side of it. Um, if you know JavaScript, sorry. So yeah, I was saying React, but I was going back into the JavaScript aspect. So if you're good in JavaScript, you'll always find that maybe you'll prefer to use React or all these other JavaScript um frameworks for your particular front end. But Yeah, so it's the only advantage that it has over maybe if you're using vanilla JS. But for this smart contract side, I always like to say it's interesting because you can use the index HTML side. Yeah, because sometimes you might not need that particular JavaScript for your backend. Maybe for example, like us here, we're using Motoko. We're not using like JavaScript for our backend or front end. Yeah, so that's just that. Um, I'm gonna wrap this particular code over here, and then I'll just come here in the dfx.json file. This is the main file where is really important. How you actually get to define this always matters. Yeah. So since you're gonna input a front end feature on it, I think I'll just add internet identity. Yeah, I think I'll just add internet identity over there to see if it can be a feature, and this particular, yeah, and then here I think it needs, let me see, oh, oops, I just need to okay, I'm just trying to put internet identity because I want this particular application that when you log in, at least you sign up with internet identity. So I'm just trying to see where I have given it injustice. This particular, oh, I think the injustice is over here, if I'm not wrong. Yes, the injustice is over there. So this particular set of code, at least maybe if you're gonna be integrating internet identity, it's always gonna come in handy for you. Yes, so I can use the Motoko package manager, the mops, the one I showed you, maybe if you wanna install it and stuff, but I won't use it. I'll just go to the one just to check out that particular token code. Yeah, so here on the backend, so I'll just come here on the ICRC2 backend folder, and I'll just create a new type of folder. I'll name it common. So just for you to help, maybe to follow through on what I'm doing, I have posted a GitHub repository on the Telegram group. You can just check it out and maybe follow through. That one is complete. Still has some bugs. Still gonna fix it. I'm still gonna push it. You can always be a contributor one way or another if you want to. Yeah. So I'm gonna create that folder, and then I'm gonna create another folder. I'm gonna name it types. Yeah, types folder. Yeah, so I'm gonna name it types folder. It's actually what I need. And then I'm gonna, under this common folder, I'm gonna add a new file now. Add a new file on it. I'm gonna name this particular file array utility folder. So an array is basically more of a list. Yeah, so just from the whole concept of array, there's more array chills.more file. I just add it there, leave it over there, and then I'll add another file over here. I'm gonna call this particular file as CRC CRC32.motoko file. So don't really mind the whole complication of the names. I'm just gonna explain them one by one and how they actually come in here. So I'm just within the common folder. I'm gonna set up another one. I'm gonna call it 24 that more SHA, yeah. And then I'm gonna add another particular file. Let me just name it text utility file. It's just the same one as the array one, yeah. So once I've added this, I'm gonna leave them. I'm not giving them any particular type of code at the moment. And then I'm gonna come here on the types folder that we added, and then I'm gonna create just two types of files over here. I'm gonna create an ICRC2 types folder, types.mo file, sorry, not folder, file, sorry, ICRC2 types.mo, yeah. And then I'm gonna input our types. I'm gonna, under the types folder, I'm still gonna create one other file. It's called types, yeah, types.mo, yeah. Yeah, so I just need those. I already have my main.motoko file. When you check out my dfx.json file, it's basically the whole backend code is gonna be on the main.mo file. So all these two folders that I've added are more of they're supporting this main.mo file. This is where actually our particular backend code will be, but this particular backend code in the main.mo file is gonna be inheriting some features from this types folder, and it's also gonna be inheriting some features from this common folder, yeah. So let's see how that goes to be step by step. Don't worry, today I'm gonna make sure I keep time because I know this series is really interesting, and since it's interesting and we want you guys to come for the meme-thon, we're gonna try as much as possible to make it spicy in a way that we're not gonna give you everything, because the whole point of you guys coming in for our particular meme-thon is to also learn, interact, build something for the future, yeah. So I'm gonna, let's see, where do we start. So here on our main.motoko file, yeah, there's some things that maybe we can start with, yeah. So the first thing that we always said, this one also applied when you were doing the Rust one, yeah. Also applies in any language. When you're building something, yeah, when you're on that particular backend code, actually when you're building even any smart contract, that means even if it's a smart contract on the Ethereum blockchain, the Bitcoin, anywhere, there's always there's always the importations. So importation features are always important because in our particular set here, which is an ICRC2 token, we actually need to import some features. You can always import them. It's just like when you're building an ERC20 token, an Ethereum smart contract token, if you're using OpenZeppelin smart contracts, when you're selecting the whole features, you'll always see an importation somewhere. The contracts always support themselves. They always inherit features in a way in themselves, yeah. Yes. Sorry for that. So I'm gonna allow me to just do some copy pasting. Time. I'm gonna import this. So the first thing I imported. So all these importations. First of all, Some of them I have imported them from the Motoko base files. So when you learn about Motoko, the whole Motoko package manager, there's some files that you'll always see in them. So I've used, like, the first import is an array. Is an array one. Another one I've used the Motoko blob. I've used the Motoko base buffer. I've used the Motoko base debug. Used the error. Have used the hash map. Hash map is very, very common. I've used the integer, representing probably whole integers and stuffs. Use an iteration, an iter. I use the NAT64 type, of course, NAT8. There's an option. Maybe all this seems foreign. There's a prelude. There's a principal. Principal is always common. Most of you who have built actually just basic smart contracts on Motoko, there's always the principal one is always mostly used. Like most Motoko code I've seen, there's always a principal set. Yeah. There's a text, there's a time, there's a boolean, which represents maybe true or false. NAT, there's a timer, result, and then interesting now here. Check out here we've imported what we actually created over here. So we created a types folder, and we created a common folder. So some of our importations are gonna be dependent on those particular set of codes, how we have actually defined them on that particular site. So you can check out, you can see here we are importing types, which actually are here on the types folder. We are inheriting ICRC2 types, which are also on the which come up from the ICRC2 file from the types folder, and the common, the array, and the text are utility ones. Yeah. So these are our particular importations that we're gonna be using. So when you declare an importation over here, it's always let's just say it's always considered that you're gonna be using this particular importation that you put. So you can't just come out of the blues and create a particular importation file. Yeah. So next step after that is I'm just gonna want us to check out check this check this yeah. So I think that's actually what I won't give the whole function names or of this, but maybe I'll just give the sake. So for example, this array is just it imports the array module from the Motoko base namespace. Yeah. Just as the whole other names, if you're coming to blob, the blob imports a blob module for Motoko namespace. Blob typically represents a binary data. Yeah. If you're talking the buffer, this imports the buffer module, of course, from the Motoko base. Buffers are used for handling raw binary data efficiently. If you're talking the debug one, it imports the debug module. It provides a functionality for debugging purposes. That's why we're gonna be using this particular importation. There's an error importation. So this error module just provides facilities for error handling. We are importing a hash map. So the hash map, it basically just it provides the functionality for creating and manipulating hash maps. There's an int one. So the int one is here, is the one that's, like I said, integers. This one is facilitates the iteration of integers. Yeah. it provides facilities for iterating over collections and stuffs, yeah. And then there's the nat 64. I explained the iter, that was the integer, but an iter is it provides the iteration for over collections, yeah. You're talking an iter, there's a whole collections behind it. So if you're coming to nat 64, that is mostly common, you've also seen it. So this imports the nat 64 module. It provides utilities for working with unsigned 64-bit integers, yeah. So that's actually what means when you're talking this particular importation, yeah. It's just a utility for working on unsigned 64-bit integers. There's another one that comes from Motoko base. It's not 8. This one just the other one leveraged the 64-bit integers. Now this one just for working with unsigned 8-bit integers. If we're coming to the option part, so this one basically it just options are in Motoko are used to represent values that may or may not be present, yeah. So that's why we're using the option one. So imagine a particular token whereby we are there's an option whereby this value might appear or this value might not appear if you're talking tokenomics behind it, yeah. And then there's a prelude time. There's a prelude importation. Here you've seen import P that comes from the Motoko base. This one is basically in full, it's a prelude. So the prelude module it typically contains fundamental definitions and functions available um, and default in the Motoko. And then there's the principal. Principal, now this one is the most common one. I'm sure in any Motoko smart contract you've come up with, you've seen import principal from the Motoko base principal. Principals are usually, I think, they're in actually almost all smart contracts that I've seen. So principals are used for representing identities and permissions in Motoko. Principal is literally you, like literally you, the developer, what particular functions are you giving that particular canister. Yeah, and then there's the text importation. So the text importation basically provides utilities for working with text strings. And then there's the time importation. This one just provides utilities for working with time and timestamps. There's the bool. The bool is a utility for working with boolean values. If it's true, yes or no, yeah. Of course, the nat, we already talked about it. It's unsigned integers. There's a timer over here. You've seen basically the timer just represents the uh, timing, scheduling, and the rest, yeah. So we also have a result. This one provides working computations that may actually fail. It gives you the whole result feature. And then there's this one looks like a red, even looks like it has a red dot. It's import prim from Motoko, that symbol. This one is usually used for forbidden or unsafe operations in Motoko. So if you're actually building on Motoko, this whole language on its own is as powerful as it actually speaks to itself. So maybe if you're providing a piece of code that maybe should not go public or maybe is still under review, you can always use this prim import feature, yeah, that might be used for accessing low-level operations that are typically not recommended in that particular set, yeah. So in our particular ICRC2 token, we're gonna be using some of that, yeah. That's why I say it's good for you to collaborate if you want. And then we also have this too. This one, of course, we imported them for them to have we imported the types that comes from the types folder because they contain the data types and definitions for this particular project. And then the common folder, which just basically it contains the utilities for working with text strings specific for this project, and also arrays and the stuffs, yeah. So Yeah, so that's basically what it means. So far so good. I'm sure this is a lot of information to take in, but you see, so far so good. This is where we've reached. We just created our default project. Started from at least the introduction basis. We created our default project, and now we are here on the importation. So our importations are set. This is actually what we're gonna be using, and I've tried explaining each at least what it means or it represents. Maybe like just try and remember maybe one, a principal one. This one is the common one, you'll always see it one way or another if you're using a Motoko language. Yeah. So our next particular piece of code is actually gonna cut us short. But after the importations, I want you to know that when you're coming to Motoko, after importations is when now the there there comes an actor model. You see, when I was showing you that small piece of code, I was showing you that there's an actor model somewhere. So our actor over here is gonna be a ledger. So maybe we can just type it actor, put it under a class and name it ledger, and yeah, and put it just like that. So actor class ledger, this is our actor model. So our actor model is gonna be called a ledger. So like you said, a ledger is really important because it's actually what defines the whole transactional values. A ledger carries your transactions, the minting and the burning features over there. So our particular token is gonna be having this. Yeah, so I think that's enough to consume for today. I'm seeing that we're 6 minutes late. We're trying as much as possible at least to keep time, so that maybe if you guys want us to continue going, maybe like to extend time. There was a proposal whereby some technical ambassadors were saying that they were like, if they do sessions they will request that we add time, but we always want first the community to at least tell us that if they should do that or not. So today I'm gonna respect your time. We're 6 minutes late, but this is where we've reached so far. I've shared the GitHub repository. We're gonna go step by step. We see how we actually got to code this particular bit and see if it's gonna deploy or not, or see which particular errors we're gonna be solving. So thank you very much for attending our particular sessions. I hope that is at least not too much and also not too little for you, and also at least I hope it's enough. So I'm also gonna just the way I've read the definitions of all this. I'm gonna write them as statements next to each, and then push the particular code so that at least you have a reminder of what you actually learned what you actually learned today. Yeah, so yes, I'm just gonna do, like, for example, I think flow forward slash, yeah, and then something like that. Just give it like a whole definition of this is an array module, it imports meaning, at least for you to understand. I think it can be better like that, because we also got feedback that we try and be a bit slowly and come slow for people to understand, and I've actually tried that. So thank you very much. I'm just gonna push it to Steve, maybe to give his remarks and end the meeting. So thank you very much, guys, for attending.
Yeah, thank you, Tevin. That was a really good session. I don't have anything else to add. Just if you guys are maybe someone lost, you can check out our YouTube channel. It contains all these Wednesday sessions that we've been having from the first one that we had about building tokens on ICP. Otherwise, just have a lovely night, and yeah, you're free to leave the call. We will send the recording by tomorrow.